Bismillahirrahmanirrahim. My name is Saad Javed and I am going to explain you about nanotechnology. It may be defined as engineering of functional systems at the molecular scale. Generally, we mean the building with the assistance of smallest particle and producing complete high-performance products. Eric Drexler in 1980s for the first time highlighted this term nanotechnology. Then about after 10 years, the US National Nanotechnology Initiative (NNI) was created to fund this technology. Its definition includes everything below 100 nanometers. The sense of making things from the bottom up was first envisioned by Richard Feynman in 1959, so he can be considered as founder of the nanotechnology. 4 generations are described by Mikhail of MNI, which include different eras. Like the current era, as Rockwell depicts it, is that of passive nanostructures materials. The second phase, which we are just entering, introduces active nanostructures for multitasking, like actuators, drug delivery devices, etc. Now you can see the figure. 4 of the types are explained with the help of an example. If we take first generation passive nanostructures, it contains dispersed and contact nanostructures. Example, aerosols, colloids. B. Product incorporating nanostructures like coatings, nanoparticle, reinforced, etc. That was back in year 2000. Now, if we consider second one, active nanostructures, bioactive health effects, example, targeted drugs, biodevices, physico-chemical active, example, 3D transistors, amplifiers, etc. Third generation contains system of nanosystems, like guided assembling, 3D networking, and new hierarchical architecture, robotics, and evolutionary. And the fourth one is the molecular nanosystems, example, molecular devices by design, atomic design, and emerging functions. This is to be considered between 2015 and 2020. Let's see what happens. Some experts may still insist that nanotechnology can refer to measurement or visualization at the scale of 1 to 100 nanometers. So we can say that nanotechnology is all about the engineering of functional systems at the molecular scale. General purpose technology. Yes, it can be considered as a general purpose technology. Like it is sometimes referred to as general purpose because in advanced form it will have significant impact on almost all industries and all areas of society. It will offer better build, longer lasting, cleaner, safer and smarter products. Let's imagine a medical device that travels through the human body to seek out and destroy small clusters of cancerous cells before they can spread or grow up. Dual use technology. US Senator Biden once said, "My own judgment is that the nanotechnology revolution has the potential to change America on a scale equal to, if not greater than, the computer revolution." From this you may consider that the words of Senator Ron Biden, that how much important is that nanotechnology, and it may have benefits and likewise there may be some risks as well. It is said to be an exponential technology because of its ability to provide high quality products at low cost and its ability to reproduce its means of reproduction, its own means of reproduction. It is a revolutionary technology, and there is no doubt about that. Now we will discuss some applications of nanoscience. How might nanoscale science and engineering improve our lives? Let us see. These are some major impacts include materials, healthcare, technology and environment, which are further subcategorized. As you can observe these three figures. Like stain resistant clothes, chemical and biological sensors, better data storage and computation. Similarly, in environment we may consider clean energy and clean air. In this figure you may observe that carbon nanotubes can be used for hydrogen fuel storage in future. Cushion of air is created about fabric, and such clothes are produced which are almost strain resistant. You may see 10 nanometer carbon viscous bond with cotton, acts like peach fuzz, many liquid rolls off. As you can see, by using nanotechnology we can prepare a protective paint, very good for cars due to their following properties. Water and dirt repellent, resistant to chipping and scratches, brighter colors, enhanced gloss. In the future could change color and self-repair. Let us find out this answer. In this figure we may observe air purifying buildings. It is possible that we can create such buildings that can be constructed with the help of nanotechnology, and the purpose can be solved. That is, air pollution can be reduced. When exposed to ultraviolet light, titanium dioxide nanoparticles in paint break down organic and inorganic pollutants that wash off in the rain. Decompose air pollutant particles like formaldehyde. That's an example. So we can say how much it is important. As you know that as solar energy is one of the most reliable and cheapest source of energy, we can use it well by this technology and make it more even cheaper and more effective one. This technology is also effective on CDs and DVDs. A DVD that could store a million movies and a very much amount of data greater than the normal CDs by normal technology. Current CD and DVD media have storage scale in micrometers. New nanomedia has a storage scale in nanometers, that is 1000 times more storage along with each dimension, that is length and width. And there you can see that 10 micrometer CD or 10 micrometer DVD, its quality and its capacity is so much increased.
I am Muhammad Umar. I will discuss advantage of nanotechnology and disadvantages as well. With the help of nanotechnology, we can build smaller devices and chips. In the field of health, very useful advantage of nanotechnology. Nerve tissues talking to computers. Neuroelectron network interface nerve cell with semiconductors. Application in brain research, biosensors, etc.
Nerve tissues. Snail neuron grown on a chip that records the neuron's activity. Healthcare, detecting disease earlier. Quantum dots glow in ultraviolet injected in mice collect the tumors, could locate as few as 10 to 100 cancer cells. As you can see, earlier tumor detecting studies in mice.
Nanofibers help heart muscle grow in lab. Filaments instruct muscles to in orderly way, not in random direction. Cardiac tissues also grows with the help of nanofiber filaments. Nanocoating prevents us from viruses. Nanotechnology also used to repair to the body, as to break apart kidney stones, clear plaque from blood vessel, and ferry drugs to tumor cell. How delicate are nanoscale size objects, and how well do we understand environmental and health impacts of nano-sized cluster of particles? Now some disadvantages of nanotechnology. Because nano devices are sensitive, radiation particles can cause fatal defects, and it requires very clean environment. Pit created by nuclear radiation hitting a mica surface. Nanoparticles could be inhaled, swallowed, or absorbed through skin. They can also affect immune system. Environmental issues. Nanoparticles could accumulate in soil, water, and plant. Additional filters are too big to catch them. It integrates chemistry, physics, biology, material engineering, earth science, and computer science. The power to collect data and manipulate particles at such a tiny scale will lead to new areas of research, better understanding, new ways to tackle problems of healthcare, energy, and environment. There are many potential benefits of nanotechnology. Most prominent benefits would be in manufacturing, medicine, and in environment. There are some potential dangers also. Weapons, rampant nanomachines, and surveillance. It would be difficult to deny the potential benefit of nanotechnology and stop development of research related to it, since it has already begun to penetrate many different fields of research. However, nanotechnology can be developed using guidelines to ensure that technology does not become too potentially harmful. There are references. Thank you very much.